Hello everyone. This video is to serve as a helpful guide for your distribution of population in Space Lab. We have like the three different distribution arrangements, and this lab is to determine that depending on whatever plant species you use. So this week, since it is so rainy, we're doing this lab in this cleared grassy plain. There's several different plants, dandelions, grass, um, along with thistles and other things. You saw right there, the goal is to throw the hula hoop behind your back to where it is randomized. You're not particularly throwing the hula hoop on top of the plant. Also, on the back of this sheet here, you see there's different directions and paces to go. So each individual is at random picking a different spot on that. And then there's the direction, and then you'll go 10 paces in that direction. This is just to help keep it randomized, to take out some of that human error, because we do not want to target our plant specifically, because that will throw off our numbers. There's an example of throwing behind the back. What I didn't get was the several paces she took in that direction. She then proceeded to throw the hula hoop behind her to leave its random chance. And they are now recording all of the number of individuals of the plant species that they chose.
Okay, so thinking a little bit about how you're going to analyze your data, on the front of your sheet, it's showing you how to determine whether or not you have a random, clumped, or uniform distribution, and you're seeing this here, which you probably can't see easily on the video, but you'll see it as you read through your handout. You're going to calculate something called a variance to mean ratio, and how to do that is within your handout here. But as you read through, you'll see that when your variance to mean ratio is equal to 1, your population is considered to be randomly distributed. When it's greater than 1, the population is clumped, and when it's less than 1, the population is uniform. So one of the issues that you have to deal with is knowing if a value is truly different than 1. So for example, if we calculate our variance to mean ratio and we get a number that tells us it's 1.1, it's hard to know if 1.1 is statistically different than the number 1. So what we're going to do is calculate something called a chi-square goodness of fit, and that calculated chi-square you can compare to a critical chi-square value. So when that calculated chi-square value is greater than the critical value, you get a significant effect. So the way that you are going to determine your calculated value is by going through the steps that you can do by hand in this handout. But your critical value, similar to the critical t-values that you calculate, come from those larger tables that are set values based on degrees of freedom. So you will calculate degrees of freedom in this exercise, and then you'll use that number and find in the Excel sheet on Moodle your actual critical chi-square. So you'll see, once you open that Excel file, you'll see in red there's a column that is set at the 0.05 level, and that's all in red text. So remember, we're always using a significant level of 0.05. So there are rows that show degrees of freedom and that critical value with that degrees of freedom, and not all the values are there. So there is a section where you can type in your own degrees of freedom if it's not shown in the table, and that will spit out your critical value. So what this actually means, when you get a significant effect, your null hypothesis is saying that you would expect a random distribution, and that your variance to mean ratio is 1. So when you get a significant effect, that's telling you that you do not have a random population and your value is different than 1. And then if it's greater than 1, you have one type of distribution pattern. Less than 1, you have another type of distribution pattern. If you get a non-significant effect, what that tells you is that you have a random distribution. So say you calculate this value of 1.1 as your variance to mean ratio, and you get a calculated chi-square that is less than the critical chi-square, you have a non-significant effect and a random distribution pattern. So say instead you calculate your variance to mean ratio and you get a value of 0.88. And this value of 0.88, once you do your calculated chi-square, let's say it's greater than your critical chi-square and you get a significant effect. What that's going to tell you then is that your population, because it's 0.88 and you had a significant effect, that your population is uniform. So that is the skinny on the statistics.
Here's the data sheet for the distribution within Space Lab. Please feel free to pause the video and screenshot this to use for your analysis. We are in the woods here at the field station and we're doing the tree and carbon part of the lab. So our group has already marked off our 10 by 10 grid. You see the little flags there and there. It's our 10 by 10 grid, and we are now measuring the DBH lengths of each tree and identifying them down to the species level. And with this, you will be able to do all of the analysis portion of your carbon lab. Where here's the DBH of this tree, mapped it all the way around like test height. And yeah, that's about it.
That's a big tree.
That is a big tree. If you have any questions regarding the analysis portion of the lab, please feel free to reach out to Professor Jen Clark or one of the TAs and they'll help you along your way. Please realize that we may not have all the time in the world, so make sure you give them enough time to respond. Thank you and have a good day.